Good morning, students. Today we are going to see about the basics of sensors and actuators of the IoT. Already we have discussed about the basics of IoT. Now let us try to understand what are the essential building blocks of IoT. One of the very essential component of IoT is sensors, and the other one is the actuators. Whereas the sensors basically sense the physical phenomena that are occurring around them, and the actuators basically based on the sensed information. And the actuators, they actuate, that means they perform some actions on the physical environment. So they take some actions based on what has been sensed, right? So essentially, if we see that we have a gradual phase wise approach to the building Internet of Things. So we have sensors which are sensing the sensors. They sense different parameters depending on the sensors being used. For example, temperature sensors, pressure sensors, humidity conditions, lighting condition, and so on. Then what will happen is these sensed information are going to send over to the connected system. That means over a network, that information will be passed. It can also involve cloud and so on, and finally that information is going to be transmitted based on what has been sensed, and based on the requirements some physical action is going to be taken by the actuator, right? So these are the things we have already discussed in the first unit. Now let us see the sensors and actuators, right, and the principles behind sensors and actuators. So sensors, as we discussed, the sensors based on the certain stimuli. The different stimuli might be there. They can be measure the thing in the physical characteristics of the environment of the system, and so on. And these changes are basically converted into the electrical signals. For example, for a heat sensor, this heat is converted to the electrical signal, and this is for temperature sensors. This for a temperature sensor, the heat is converted to the electrical signals, and for the sensors such as atmospheric pressures, atmospheric pressure sensors, it is also converted to the electrical signals. So we have different sensors which measure the different things, but the sensed values are converted to the respective electrical signals, right? Next, going to see about the transducers. After that, we will see the actuators, right? Already we have discussed, right? The sensor is often defined as the device that receives and responds to the signal or any stimuli. The set of signals, the set of characteristics of a signal format. The sensor has input properties and the electrical output properties, right? So we have discussed before. And then transducer. Transducer converts or transduce the energy of one kind into the another. For example, a sound system, a microphone converts the sound waves into the electrical signals for an amplifier to amplify. That is means amplify. It means a process, and a louder. The electrical signals for an amplifier to amplify a process. If you take a loudspeaker as an output device, it converts these electrical signals back into a sound waves. So now there is a associated terminology which is for the transducers, right? The sound waves are converted into the electrical signal, then to output devices like a loudspeaker, and we are able to hear that sound. This is also an example of a transducer. If you compare the sensors versus transducer, the word transducer is a collective term used for both sensors, which can be used to sense a wide range of different energy forms such as movement, electrical signals, radiant energy, thermal or magnetic energy, and etc. And actuators, which can be used to switch the voltage or current. These terms, the terms sensors and transducers, are very common. They have a lot of overlap, and we have to understand the distinction between these two. There is a lot of misunderstanding. People convince the sensors and transducers, right? So the word transducer is a collective term which includes the sensors as well as the actuators, right? Hope so everyone understand the sensors versus transducer, right? The sensors have a different features. They are the sensitive to the property, the physical property that is being measured. So they can do all. They are sensitive only to that measured property. So basically a temperature sensor can sense only the ambient temperature of the room. It is insensitive to the other changes, maybe changes in the atmospheric pressure or changes in the lighting condition of that room, right? Next we will discuss the classifications of sensors. First one is the passive and another one is the active sensors. The passive sensor does not need any additional energy source and directly generates an electrical signals in response to the external stimulus. That is, the input stimulus energy is converted by the sensor into the output signals. For example, thermocouple or piezoelectric sensors. And active sensors require the external power for their operation. This is called excitation signal. That signal is modified by the sensors to produce the output signal. The active sensors sometimes are called as a parametric because their own properties change in the response to the external effect, and these properties can be subsequently converted into the electrical signals. It can be stated that the sensor's parameters modulates the excitation signal, and that modulation carries the information of a measured value. Here the example is the thermistor. It is a temperature sensitive resistors. Okay, this is the two types of classifications of sensors. Next very important one is sensor resolution. The resolution of the sensor is the smallest change it can detect in the quality. It can detect in the quantity that it is measuring. The resolution of the sensor with the digital output is usually the smallest resolution the digital output is capable of processing. Alright, the more is the resolution of the sensor, the more accurate is its precision. Right, the sensor accuracy does not depend on the resolution. Okay, next one is the sensor classes. The sensor classes, it is based on the output. The sensors can be classified as analog or digital, and it is based on the data type. They can be classified into a scalar, right, a scalar or vector sensors. So in the analog sensor, what we have, the sensors give continuous analog output. If you take an example, tilt temperature sensors continuously changes in the temperature going to the sensed, measured, and the output is going to be analog signal. The digital sensor basically gives the digital output on and off at their binary value 0 and 1. For example, like this, the discrete signal values given as output by this digital sensors. And if you take a scalar, sensors basically measure the scalar variables which can measure only the changes in the magnitude, whereas the vector sensors can not only the magnitude but also take it as a directions also. Already we know that, right, the difference of scalar and vectors. So the scalar sensor example would be take the temperature sensor is an example of scalar sensor, because you know the irrespective of which orientation you put the sensor temperature, the temperature sensor or in which direction you are taking it, it is going to give you the magnitude value. Only the changes in the magnitude of the temperature. On the contrary, we have the vector sensor. For example, the camera sensor or the accelerator sensor, whose values are depend on the orientation, on the direction, and so on. right, and the direction in which the sensor is being put and the weight is measuring. So it is depend on that. We have analog sensors. Finally we know that, right, we have the analog signal, analog, digital, scalar, and vector sensors. Already this case, but once again I will tell you the analog sensor is a temperature sensor. The temperature is typically measured with the help of thermometer or thermocouple thermometers. These are all quite common, but thermocouple is something that is used in the geysers. There are two different metallic strips, for instance, and these strips, they can in the thermocouple they can bend so on. So this based on that, based on the amount of bending, right, they measure the changes in the temperature. If you calibrate the thermocouple, giving how much the temperature has changed, and depending on one can understand how much the liquid has heated up or cooled down, right. Next one, the digital sensors. It is a very simple digital discrete voltage levels, or the signal levels, right. It have a binary value 0 or 1, or on and off condition, right. Next one is the scalar sensors. It measure only the magnitude of physical quantities such as temperature, color, pressure, strain, etc. Right. Next one is the vector sensors. They produce the output signal of the voltage, which is generally proportional to the magnitude as well as the direction and the orientation of the quantity that is being measured, right. And the physical quantities such as the sound, image, velocity, acceleration, right, these are all vector quantities, and their measurement does not just depend on the magnitude but also the direction, right. So for example, the accelerometer sensor, which gives the output in three different dimensions, x, y, and z coordinate axis, right. The next topic is sensor types. The sensor types, there are some examples of different sensors, right. If you take the light sensor, it used to measure the light. We have a LDR sensor, right, light dependent resistor, which is the light dependent resistor photodiodes. This can be act as a sensor for measurement of light, for sensing of light. And if you take a temperature sensor, we have a thermocouple and thermistor. We have discussed before, right. And next one is force, which have a strain cause or pressure switch, right. And the pressure switch for position, we have potentiometers, encoders, and optocouplers, I think, right. And the optocouplers basically so the optical signals are the optical rays are abstracted, and based on the position information can be obtained, right. And speed sensor, you have to sensing the speed of couplers, right, optocouplers and other mechanical motions, right. And next one is sound sensors. The carbon microphone, it's like our existing traditional microphones, and the piezo crystals and so on. And chemical sensors, we have the liquid chemical sensors and gas chemical sensors and etc., right. So if you have a time, please see the pictures of all those sensors and get some knowledge behind it, and also refer some of the sensors, ultrasonic level sensors, ultrasonic distance sensors, right. These sensors are sense the level. If you fill any bottle, whether it fill the required level or not, using the sensor you can sense it. Tilt sensor, if you tilt any objects, it automatically gives some information to you. And motion sensors, camera sensor, temperature sensors, we have lot of sensors, right. Each and every thing you have to sense it, right. And the next topic is sensor classification. already we have classified, right? One is passive and active. Like we have another one is absolute and relative. An absolute sensor detects a stimulus in reference to the absolute physical scale that is independent of the measurement conditions, whereas the relative sensor produces a signal that relates to some special case. Yeah, the example of absolute sensor is thermostat, right? And a temperature sensitive resistor. It is a electrical resistance directly relates to the absolute temperature scale of Kelvin. If you take the relative sensors, the example is atmospheric pressure, right? Have you understand the difference of absolute relative sensors? If you listen, please come to the discussion forum, or when we do the meeting, kindly ask some queries related to this, right? And let us see the actuators, right? It's very quite interesting topic, actuators. Based on the readings of sensor, we have already seen the different types of sensors, right, in the previous lecture. And based on the readings of these different types of sensors, some actions might be required to be taken, and that is done by the actuators. These actuators basically perform certain actions on the environment, on different based on the environment, on any other system on a device. Right, there are different examples we have. I will post the pictures of some of the actuators, right? I will give some of the examples. Before that, I will define the actuator. Actuator is a component of a machine or a system that moves or controls the mechanism of the system. So typically these actuators are based on some control system, and this control system, they act on the environment. So and the actuator basically requires some kind of control signal and a source of energy for their functioning, right? When these actuators receive a control signal, they respond by converting that energy into a mechanical motion. So mechanically something is going to be done. This is to be convert the electrical signal, some control signal, into a mechanical motion, and that control system can be simple, which can be based on some mechanical or electronic system, or it can be a software based like printer, driver, robot, or any other controlling systems, right? And types of actuators here I have put, right: hydraulic, pneumatic, electrical, thermal, and mechanical. So when we do a hydraulic actuators, it consists of a cylinder or fluid motor that uses a hydraulic power to facilitate the mechanical operations, right? When some fluid passes through, the motion converted into the linear motion or accelerating motion or rotatory motion, and since the liquids are nearly impossible to compress, most of the hydraulic actuators basically exert the considerable force, right? The pneumatic actuators, this means a air-based sensor, air-based actuator. The pneumatic actuator basically converts the energy formed by the vacuum or compressed air at a high pressure into either linear or rotatory motion, right? Next one is electric actuators. We have electric actuators is generally powered by a motor that converts electrical energy into the mechanical torque. This electrical energy is used to actuate the equipment such as a solenoid valve, which control the flow of water and pipes in response to the electrical signals, and it works on the principle of an electrical actuator. Next one is the thermal or magnetic actuators. It is actuated by applying the thermal or magnetic energy. It tend to be compact, lightweight, economical with a high power density. Okay. Here they have using SMA. SMA, it is shape memory alloy. It is It is based on piezometer. I will show you the piezometer works um, in further videos. Okay, and next one is the mechanical actuators. It converts a rotatory motion into a linear motion to execute some movement, and it involves gears, rails, pulleys, chains, and other devices to operate. Here the example is rack and pinion, right? You saw those equipments, this rack and component, right? Rack and pinions, right? And other actuators also, we have soft actuators. These are all the actuators you have to work in the agricultural field, and handle the fragile objects like fruit harvesting, and manipulating those internal organs in your biomedicine, right? Those actuators we call as a soft actuators, right? So, right, these are some of the types of actuators. Next we will see the examples of sensor and actuators of IoT, that is like the principles behind it. Right, here I have used one of the sensors, that is soil moisture sensor. This moisture sensor used to detect the soil moisture content, and get those information from the soil, and put it to and sends to those information, and detect the values of humidity of the sensor and temperature of this soil. All those things have to be get, and pass it to the control center. It sends commands to the water pump. This water pump depends upon the soil moisture content. It pours the water to a soil, right? This is one of the example, and another one is quite interesting example, the beverage brewing machine, right? This beverage brewing machine is very much interesting one. Let us see the beverage brewing machine.